Hi, my name is Muhammad Aslam bin Azmi. Firstly, I'm going to present about introduction, topology optimization of forklift. Then, introduce an important influence on the forklift force, overall performance, and the job security of the fork structures parameters. It emphasizes the pros and cons of the mechanical properties of the forklift fork structure. Since analyze the simplified fork structures and the rate payload, then accomplish the static analysis based on SolidWorks 2020. Furthermore, inquire the maximum stress factor of safety and deformation of the fork under the rate payload, which supplied by a theoretical reference for the optimized design of the forklift forks. For the background of forklift fork design, the strength and rigidity of the fork are essential to the operation of the forklift and the safety of the operator. The work serves as the foundation for the analysis. The forklift fork structural parameters should be optimized based on the finding of the finite element model. Because the fork is firmly connected to the forklift frame, it is necessary to address the vibration caused by the fork deflection. For the topology optimization, design is well established technique used to determine the optimal material distribution under specific conditions to achieve the best structural performance. In general, topology optimization takes a model of a section and exercise bit from it until a specified goal is achieved. The objective could be to find the stiffest configuration possible while utilizing the least amount of material. This innovation starts with plain space that allow and allot a certain value of work calculation that used to remove fragments of this value until only an ideal division remains. For analyzing forklift forks, finite element analysis software was used to investigate the mechanical properties of a hanger type forks with a light load and high work efficiency. When failure occurs, finite element model determine the design process of casting beam in a forklift, and this study was able to provide a solution. Finite element techniques and structural strength calculation based on computer-aided design and finite element methods that have been facilitated by numerical simulation technology. The aim is to arrive at the optimal design given a set of priorities and constraints. This includes increased productivity, strength, dependability, lifespan, efficiency, and ease to use. For SolidWorks 2020 software, SolidWorks it has simulation with a new function called topology optimization. With this technology, it can automatically determine the optimal design. Pupils may either export the optimal geometry as a solid body for use in their design or redesign their component using the best geometry. For the problem statement of the forklift forks, since forklifts are regularly used, problems will likely occur, resulting in increased downtime and improved safety concerns. Then, Recently, a hydraulic hose on forklift truck failed, resulting in dramatic drop of the item being lifted. And then, no cracks were identified in the fork during normal inspection conducted a few months prior to the accident using liquid penetrate. Then the investigation demonstrated that harsh service circumstances were the cause of fatty cracks developed inside the hull of forklift forks. The objective of optimization forklift forks: firstly, to optimize the original forklift forks model by using optimization of the SolidWorks 2020 software topologies. Then, to reduce the design of forklift forks by enhance its strength and stiffness. Next, to represent the final element model of the forklift forks design in order to improve the safety factor and alleviate issue with the forklift lift mechanism. Scope of project: topology optimization of forklift forks. The forklift was designed and developed entirely around the fork's most critical features. The forklift fork's finite element analysis was then performed using SolidWorks software, with the result being a static study that demonstrates significant stress and deformation. Thus, SolidWorks 2020 software assists in optimize the design by redesign the fork also with SolidWorks to present the best outcome and be provided in this report.
My name is Muhammad Nafaris bin Saiful Azman. So today I'm gonna present about the methodology of the topology optimization for the forklift. This is our methodology flowchart. We begin with the design of the CAD model, which is the forklift fork, and then we follow up with the FEA analysis to the product. Thirdly, we going to do the topology optimization to the product, and then we do the redesign of the model, and after that we do the FEA validation to the new redesigned product, and then we go for the report. For the product part, we select the fork of the forklift to be our design product, which is the fork always used to lift the wood pellet in the industry. So this is our design of the fork. We are using the SolidWorks to design this fork. So this is the dimension of the product. We take the real dimension of the product to be our design. For the material properties, we are select the IC 4130 steel as our material, which is this material always used by the company to make the forklift. The yield strength for this properties is 460 MPa megapascal, and the tensile strength for this material is 731 megapascal. This is how our group do the simulation to the product. We put the fixed support at the back of the product, and we apply the load on the distributed load on the face of the fork with the 1000 Newton. The result from the FEA analysis, we got the maximum von Mises stress. The maximum stress we got from this analysis is 37.29 megapascal. And for the total deformation, we got the maximum deformation of this product is 4.103 millimeter. For the safety factor of this product, we got the safety factor 12.34 to this product, which is we calculate the safety factor by ultimate stress and actual stress from this product. Next, we do the topology optimization, which is used to maximize the output of the structure. We reduce the mass about 70%. We success to reduce the mass from the 43.0213 kg to 12.906 kg. These are the result of the topology optimization that we get from the analysis. So this is the side view and the bottom view of the product. After get the result from the topology optimization, we do the redesign to this product, and this is the result of the redesign of our product. After do the redesign to the product, we analysis to the model, to the new model, and we got the result from the analysis, and the result of the maximum von Mises stress for this new product is maximum stress we got the 83.72 megapascal for this product. For the total deformation of the product, we got the maximum deformation 10.85 millimeter. That's all from me, thank you. Next slide will be presented by Amri. He will present the result of the project. That's all from me. Thanks.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amri bin Azizuddin. I want to share about the result and discussion for this project. Okay. For the result and discussion, we just compared between the original design and optimized design features. At the left side is the original design, and the right side is topology optimized design. The comparison includes the features of mass, maximum stress, total deformation, and factor of safety. First, mass. From both original design and topology optimization analysis, we succeed to minimize the mass by 70%, which is from 43.02 kg to 12.91 kg. For the maximum stress, both original design and the topology optimization design show the result is from 37.29 megapascal to 83.72 megapascal. This indicate an increase in maximum stress by 124%. For the total deformation, the table shows the total deformation for the original design is 4.013 mm, while the topology optimization analysis design is 10.85 mm. There are 170 increasing from the original design. Last, the factor of safety. For the factor of safety for this part, which is for default, we discovered that the original design is 12.34, and for the topology optimization analysis is 5.49. The result obtained from the analysis, they are slightly different for the factor of safety. However, the factor of safety for both analysis show the product is still reliable and well founded because the value is in the safety range. Therefore, the topology optimization design is acceptable.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hairi Arif bin Mat Zaini and I will talk about summary. To summarize, design optimization is required in the manufacturing process to reduce raw material consumption and cost while maintaining the product's robustness. In principle, the product that was tested using finite element analysis was created using CAD software, which identifies a product's weak points by analyzing it using the von Mises theory implemented in that software, as well as calculating the safety factor. Additionally, it can optimize the product to conserve raw materials that would have been used in the original shape. Thus, this article examines the structural stability of the fork safety significance using mechanical model of the fork. The fork was determined using SolidWorks finite element modeling and analysis. Static analysis was used to determine the stress-strain characteristics of the fork arm. Then, stress-strain curves on the fork arm were generated, fork safety reference checking was performed, and the structure of the design was optimized. That's all from me. Thank you.